So we talked about electrolysis. We talked about cathode and anode. That at cathode, electrons are gained, and at anode, electrons are lost. There's going to be reduction. Anything that appears at cathode, the battery is going to give it electrons, so there is no choice. The only thing that it's going to do is gain electrons. Anything that appears at the anode is going to lose electrons. Negative ions appear at anode, and positive ions are attracted to cathode. And if it's an aqueous solution, there's going to be water molecules. Remember, there's not going to be any H+1, or there's not going to be any OH ions. Water doesn't ionize a lot. So this is one thing that you have to be careful. This is something that's different from O-levels. And so you're going to look for equations in the data booklet where copper 2+ or water gain electrons. And I think we had the data booklet over here. So you're going to look for the equation in the forward direction where copper 2+ gains electrons. So you find copper 2+ on the left side, and it's supposed to gain electrons in the forward direction. Remember, there is not going to be any reversible sign because copper 2+ has no choice. It can only gain electrons. Now the choice is gone. So you look for two equations for copper 2+. For water, the same thing happens. You go and have a look, and you'll notice that there is only one equation where water gains 2 electrons to form H2 and OH ions, and it has a potential of minus 0.83 volts. So you've got 3 potentials. And who gains electrons? The one that has the high E0. That has the highest tendency to actually gain electron, and that comes out to be copper 2+. So copper 2+ is going to gain electrons, and that's your equation at cathode. At anode, you're going to find equations where either SO4 - 2 or H2O lose electrons. Now, if you want them to lose electrons, you're going to open the data booklet, and you're going to look for the equations in the reverse direction. So you're going to go and have a look at the equations in the reverse direction where you want water to lose electrons. So you got 2 equations for that, 1.77 and 1.23, and you would have one equation for SO4 - 2 that it would also lose electrons. And who loses electrons out of the 3? It's going to be the one that has the lowest potential, which comes out to be 1.23 volts. So over here, 1.23 volts is the one that's going to win. So remember, you don't have a choice. Now the reactions are not reversible. This would always be reduction, lose electrons. This side over here would always be gain of electrons. So I'm just going to quickly do one random example of some other substance. Let's talk about AGBr. And I'm going to make things slightly different. What I'm going to do is, just a second, So I'm going to make things slightly different. Now I'm going to use an active electrode, which means it's going to be made out of a metal, which is going to be slightly reactive. So let me copy this diagram for electrolysis. So here's my electrolysis diagram. Reduction would happen on one side, gain of electrons, loss of electrons on the other side. Now, what I'm going to do is I have, let's say, AGBr aqueous in the solution. So I've got AGBr, and it's an aqueous solution. Although AGBr is probably not that soluble, but let's have an aqueous solution. Let's think of it as 1 mole per dm cube. And the electrodes now are made out of silver. So I've got silver electrodes. So these are made from a metal. The solution contains Ag+1, and it contains the Ag+1 is going to be attracted to the cathode, and it contains Br -1, which is going to be attracted to the anode, and it contains water because it's aqueous. So you've got water over here and water on the other side. It's a neutral molecule, so it would appear everywhere. In aqueous solution, water would be everywhere. So who's going to lose electrons? It's going to be either Br -1 or it's going to be H2O. One of them likes to really lose electrons. And who's going to gain electrons? It's either going to be Ag+1 or it's going to be water. So quickly I'm going to try and look for equations. Now remember, if it's made from silver, if this is made from silver, then you have to take that into consideration as well, because you've got an option where silver could also gain electrons. So I'm going to look for equations where silver gains electrons. or water gains electrons. For water, the equations are the same, so I'll just copy that equation. It's the same reaction. And since water is on both sides, so I'm going to copy both water reactions. So here's my water reaction, and the other one is, I'm going to add the water reactions on the other side as well, where they lose electrons. So I'm going to rub this. I mean, at the moment, I haven't selected which reaction will happen, so I'm just writing down all possible reactions. So for water, I've written that. I'm going to add one for Ag+1 where it gains electrons. So let's open the data booklet and find out where is Ag. Ag is going to be in A. So the first one over here, that's your Ag+1, and it's gaining electrons. So you've got Ag+1 that's gaining electrons. I'm going to write that down. It's so this one. One second, let me copy that. Ag+1 gaining 1 electrons. And it's forming silver. And the value is 0.8080 volts. So I found an equation for Ag+1. I found this equation, Ag+1 gaining 1 electron. Now you have to keep this in mind as well. This is silver. So if there were an equation where silver is gaining electrons, you should write that down as well. But if you look at the data booklet, there is no equation where silver atoms are gaining electrons. They don't form negative ions. So this one is out of contention. This is the metal electrode is not going to be the one that would be gaining electrons. So I'm considering the metal electrode as well. So remember, if the electrode is made out of a metal, consider that as well. So you've got 3 options. One, either the ion or the water molecule. One of the 3 is going to be gaining electrons. So I didn't find any equation where silver is gaining electrons. So I'm going to not write any equations for that. Now over here, we have 3 options now. Who's going to lose electrons to the battery? You've got a silver atom that could lose electrons. The metal electrode is made out of silver. You've got Br-1 in the solution. You've got water as well. So the Br-1 equation. So our Br-1 equation is, what's our Br-1 equation? I mean, it's given in the data booklet.
So how do you,
Haji?
I mean, हम select कैसे करते हैं? I mean, how do we figure out कि कौन सा ion या atom will gain or lose an electron?
I mean, is the first part clear? Okay, it's going to be either one of them. It's either going to be silver because it's made out of silver, or it's going to be Br-1, or it's going to be water. Okay? One of the 3 would be the one that would be losing electrons. Is that clear? But ये वाला part तो clear है ना? Ibrahim, is this clear?